Welcome to 3-1 Measures of Center. And we're going to start off with the mean, also called the arithmetic mean. And basically, it's what we have always called the average. When you talk about the average of things, that's what the mean is. In statistics, we do not call it the average, we call it the mean. So the mean of a set of data is the measure of center found by adding all the data values and dividing the total by the number of data values. For example, let's say we want to find the average of your grades. Let's say I have a table, and in this table we have, we'll call it quiz 1, quiz 2, quiz 3. And we have our grades. So on quiz 1, we got a 90. On quiz 2, we got an 80. And on quiz 3, we got a 92. And I want to know what my mean is, which is the same as if you asked me what your average is. So this is my data. And it says by adding all the data values. So these are my data values. So I'm going to add 90 plus 80 plus 92. And then I divide by the total of the number of data values. How many data values do I have? 1, 2, 3. So I have 3 values. I'm going to divide this by 3. And I get, let's see, 170, 262 equals 87.33. So now I know what my grade point average is. If you're talking about our class, this is probably a B+. That's basically how you find averages, which is the same as how you find means. So the mean and the average are the same. Important properties of the mean. We have a sample means drawn from the same population tend to vary less than other measures of center. What does that mean? If we draw from a sample and we find the mean of that, it should be similar to the mean of the entire population. The mean of a data set uses every data value. So if we want to find the mean, we need to use every value. We're not going to leave any out. A disadvantage of the mean is that just one extreme outlier can change the value of the mean substantially. About resistant in a minute. But what this means is, let's say I have 3 numbers, 1 plus 2 plus 3. And since I have 3 numbers, I'm going to divide it by 3. This is equal to 6 over 3, which equals 2. So this is my mean. But if I have one outlier, let's say I have 1 plus 2 plus 3, and let's add one more number that's an outlier. An outlier means it's not close to the rest of my data. And I divide this by 4 because now I have 4 numbers. Well, now I have 106 divided by 4, which is 26.5. One outlier, this would be considered an outlier. It's nowhere near the rest of my data. And look how much it changed my mean, because this is my new mean with just one value more that's an outlier. What this is saying is that if I have just one extreme case, it could really throw my entire mean off. A statistic is resistant if the presence of an extreme value or outlier does not cause it to change very much. As we just saw, mean is not resistant. Mean is not resistant. one change in value, and I changed the mean quite a bit. So we have this different notation, and I just want to describe it because you will see it. You won't need to use it very often because we do have StatCrunch, and StatCrunch will do most of the work for you. But we have this symbol. This is called sigma. And what it means is just to sum, which is the same as add, all the values together. If I say I have values in a set, let's say 10, 12, 15, 17, and I'll call this X. X is equal to all those values. I want to sum all the values in X. That would be the same as saying 10 plus 12 plus 15 plus 17. That's really all it means. X is the variable usually used to represent the individual data values. So when I have a bunch of values, I usually call them X. N represents the total number of data values in a sample. For example, in this sample here that I just wrote down up here, there are 4 data values. 1, 2, 3, 4. For this, N would equal 4. If we use the entire population, we use capital N. It's very rare we use an entire population to find information about anything. It's usually too much. We try to find a sample that will represent the population. Then we have X bar. It's an X with a bar on the top of it, and it's pronounced X bar, and it's the mean of a set of sample values. If I see something that looks like X bar, what I'm going to do is I add all the numbers together and divide by the number of values. Just notation, don't let it get the best of you. And the only difference between X bar and mu, so X bar is the mean for a sample, and mu, which is a Greek letter, is the mean of the population. We're going to go to data set 32. This is data set 32. Airport data speed includes the measure of data speeds of smartphones from 4 different carriers. Find the mean of the first 5 data speeds for Verizon. Is I need to open StatCrunch because I can open it on its own. I don't need Pearson to open it. I do need to have Pearson open to use it though. It said, find the mean of the first 5 data speeds for Verizon. I'm going to come here. I'm going to pick 1, 2, 3, 4, 5. Let me copy it. I'm coming in here to our StatCrunch. I'm going to paste it in. I don't need really anything else. So it says, find the mean. Okay. So what we do in StatCrunch is we go to Stat, Summary Stats, and it's all in a column, right? So we're going to go to Column. We're going to pick Verizon. And then these are all the different things that we can use. I don't really want variance. I don't want standard deviation. I don't want standard error. Those are the ones that they're coming with automatically. Do I want median? Nope. All I want is mean. That's the only thing it's asking me for. So I'm going to take everything else away and gives me the number. And let's hit compute. And there we have it. Without much work at all, I have 1, 2, 3, 4, 5 pieces of data. 1, 2, 3, 4, 5. And there's N is 5 from Verizon. And there's my mean. That was pretty easy. If I added up all these values and I divided by 5, I would get 30.74, which is exactly what I got just by using StatCrunch.